Dr. Fauci, knowing that it is a crime to lie to Congress, do you wish to retract your statement of May 11th where you claimed that the NIH never funded gain-of-function research in Wuhan?
Senator Paul, I have never lied before the Congress, and I do not retract that statement.
Take an animal virus and you increase its transmissibility to humans.
Right.
You're saying that's not gain-of-function?
Yeah, that is correct. And Senator Paul, you do not know what you are talking about.
This is your definition that you guys wrote. It says that scientific research that increases the transmissibility among mammals is gain-of-function. They took animal viruses that only occur in animals and they increased their transmissibility to humans. How you can say that is not gain-of-function?
It is not.
It's a dance, and you're dancing around this because you're trying to obscure responsibility for 4 million people dying around the world.
Thank you very much, Harvey. It's a great pleasure to be here with you this morning. I want to take this opportunity, as you see on this first slide, to first welcome you all. I know I see so many friends and colleagues in the room who have traveled a great distance to be here with us today to discuss this extraordinarily important topic, but also to give a brief overview, as Harvey said, a considerable amount of the activity that goes on in this area from a research standpoint comes from the NIH and NIAID. As you know, we're part of the Department of Health and Human Services, as is the Centers for Disease Control and Prevention, who also have a considerable amount of contributions, both from a public health surveillance as well as from a research standpoint, in the topic for today, which is gain-of-function research on highly pathogenic avian influenza H5N1. So what I'd like to do is to give you a perspective historically, briefly, but historically, about how we got here today to discuss with you in an open forum represented by many different perspectives in the questions that we'll be asking today. So from the standpoint of research in general, we at the NIH and the CDC have been involved in the study of influenza literally for decades and decades. I don't need to tell this audience, but I know there are those who are listening in who may not have the historical perspective, is that seasonal influenza itself is an extraordinary threat to global health, resulting in approximately 500,000 deaths per year worldwide. Every once in a while, unpredictably, we have a pandemic. History has shown us that pandemics occur and almost certainly will continue to occur. On this slide, you see the history from the last century and this century of the now iconic pandemic influenza of 1918, which killed between 50 and 100 million people. A serious pandemic in 1957, again in 68, and then most recently in 2009, the first of the pandemics of the 21st century. Now, highly pathogenic avian influenza, as you've heard from Sally, is widespread among poultry in parts of Asia and the Middle East. Infections of humans, i.e. jumping species, is rare, but when it occurs and causes severe respiratory illness. Currently, this virus is not well adapted for sustained human-to-human transmission, but there is concern that has been going on now for approximately a decade. In fact, the first cases were in 1997, but since 2003, there has been considerable concern that the virus may ultimately acquire the ability to adapt itself better for human-to-human transmission. This is the now familiar map of the worldwide cases as of just a few weeks ago. As Sally mentioned, there are about 600 cases, but importantly, and I'm going to get back to that in a moment, because this is one of the issues which actually brings us here today and caused the discussion that has been intense over the last 13 to 14 months, and that is the 59%, the reported 59% mortality, which makes this a most unusual, smoldering pre-pandemic threat. Now, back in 2003, when the cases began to accumulate, there was considerable concern at the highest level of the federal government, including HHS, which, as you know, is the one with the biggest stake from the standpoint of action in this area. So on this slide, you see in November of 2005, the federal government came out with a pandemic influenza plan, and immediately thereafter, as part of that, HHS came out with our pandemic influenza plan, and then the next year, an implementation plan came out. I tell you this because some of you, as I know in our discussions, are not fully appreciative of the historical nature of how we started getting involved in an intensified research in this arena. On the right-hand side of the slide, you see the strategy and implementations that were outlined in these documents. And this is one that comes from our HHS pandemic plan. International and domestic surveillance, vaccines, antivirals, communications, and state and local preparedness. Several of these mandates were for the CDC, several for the NIH, and some overlapped between the two agencies. The two we're going to focus on now is vaccines and antivirals, which was the mandate that we as a research institution were given as part of our already ongoing decades of work on influenza in general. As part of our research endeavors, clearly interventions in the form of diagnostics, therapeutics, and vaccines were important. But on the lower part of the slide, you see basic research. And that has always been and will continue to be an important part of our mission and our activities. If you look at basic research as we've approached it through the years, long antedating the appearance of H5N1 highly pathogenic virus, as part of that influenza basic research was intensive study of host adaptation, transmissibility of influenza viruses, pathogenesis, and virulence. And integral to that study has always been the issue of gain of function research, not only for influenza, but essentially for all infectious diseases research. Now, there are a few ways to look at gain of function research. There's the naturally occurring mutations which naturally give gain of function, and investigators study these effects on the phenotypes of interest. Does this mutation make something more transmissible, more pathogenic, or adapt to host better? Or, what historically investigators have done is to actually create gain of function by making mutations, passage adaptation, or other newer genetic techniques such as reverse genetics and genetic reassortment. When we do that, often some phenotypes appear and others disappear. For example, it is commonly seen that when you increase a transmissibility, you may see a decrease in pathogenesis, or vice versa. You may deliberately increase pathogenesis and see a decrease in transmissibility. But the bottom line is that gain and loss of function research is critical to understanding disease pathogenesis, antimicrobial resistance, and host responses, as well as to developing better techniques of surveillance, vaccines, and therapeutics. Specifically, to gain of function research on HPAI, H5N1. What we're talking about now is the gain of function research in studies that increase predominantly the transmissibility, as is the case that I'm going to get into in a moment, as well as pathogenesis and alteration of host range of the virus. Now, the reason we are here today in this room with H5N1, highly pathogenic influenza, and we're not in this room discussing so many of the other gain of function research that we do, is because naturally occurring HPAI, H5N1 viruses cause a reported almost 60% mortality in humans, which triggered a concern, understandably, clearly, that if you give a gain of function of a pathogenic virus to make it more transmissible, that's a whole different story than some of the other things we faced. So let's get down to what happened very briefly. You know historically, and I'm going to go very quickly through the historical perspective that brought us here today. There were studies done by two NIH, NIAID-funded investigators, Ron Fouché and Yoshi Kawaoka, in which H5N1, a strain from Indonesia and a strain from Vietnam, were altered in a gain of function, either by direct mutation or by reassortment. And by passage in ferrets, the mammal model for this virus, for humans, there was an increase in fact, a development of aerosol transmissibility in a mammal, which this particular virus did not have. Because of that, this triggered concern. This was after the experiments had been done and after they had been submitted to the journals. And from this press statement, we put it before our National Science Advisory Board for Biosecurity here at NIH, which is representative and advisory to the entire department of HHS as well as to other agencies. And the conclusion was made, and this is critically important for us to understand, and I take this right out of the statement that came from the NSABB, that due to the importance of the findings to the public health and research communities, the NSABB recommended that the general conclusions highlighting the novel outcome be published, but the manuscript did not include methodologic and other details that could enable replication of the experiments by those who would seek to do harm. What also was discussed that might accidentally be released, so it is not just people who would deliberately do harm. As Sally mentioned, following that, there was an explosion of reaction, sometimes bordering on the very extreme, as shown by this editorial from the New York Times, an engineered doomsday. This is just one, but as some of you may recall, there was a lot of activity talking about worst-case scenarios where the world might be destroyed. In that setting, the influenza community voluntarily imposed upon themselves a pause of 60 days from January 2012 on any research involving highly pathogenic avian influenza virus, leading to the generation of viruses that are more transmissible in mammals. That was supposed to be a 60-day, and as you know, the moratorium is still in place, the voluntary moratorium on the part of the investigators. But soon thereafter, there began to be an open discussion clarifying that research in different fora outside of the NSABB. The NIH and the CDC, because we do similar work, also agreed that we, in our own intramural investigators, we would refrain from these types of experiments and essentially abide by the moratorium that was signed on by a significant number of our extramural investigators. And I'm talking about the investigators at NIAID and other institutes as well as the CDC. From there came open discussion. Many of you remember the meeting in Geneva in February of 2012, where importantly new data were presented and even more importantly original data was substantially clarified, which led that group, which was predominantly influenza people, with a consensus to delay publication, but ultimately to publish them after there had been some more emphasis and discussion of safety, public health, and communication issues, but also they recommended to extend the moratorium in order to have further discussion, as well as reaffirming the PIP agreement. Then back in the United States, what happened was a series, as you can see from the dates on these, of open discussions in different forums. There was a meeting sponsored by the ASM on biodefense, shown here, the people who were a part of the panel, myself included, Bruce Alberts of Science, Mike Osterholm of the NSABB, and Ron Fouché, one of the investigators, and we discussed openly the situation of the publishing of these data and the experiments that would be performed. The NSABB re-met the next month, and they examined the revised manuscripts with the clarification of data, and they voted unanimously to have Kawaoka manuscript be communicated in full, and in the 12-6 decision also that the Fauci manuscript be communicated after appropriate scientific review and revision, which, as you'll see in a second, actually occurred. Then we had a National Academy of Science workshop where we looked at the lessons learned. How did we get to where we were, and what do we need to do in the future to proceed in a responsible manner? The next day, the publication of the manuscripts occurred, as shown here in the Nature and Science titles. But the discussion continued, and one of the questions that was asked by the investigators, since this was a voluntary moratorium on their part, is how long is this moratorium going to go on, and what are really going to be some of the guidelines that we could actually follow on the basis of this? We at NIAID, being the major funders of most but not all of these people, we obviously were connected to that because they wanted to know, since you're our major funders, what kind of research will you fund? There was a major meeting of the Centers of Excellence for Influenza Research and Surveillance this past summer, at the end of July and the beginning of August. And as many of you know, I went up there to address the group. And what I recommended is that they continue the moratorium, but that we have the opportunity to discuss in an open fashion that is not only influenza researchers, but people like yourselves.